Hey everyone, and welcome to this Forge College Explainer. I am absolutely thrilled to have you here today. We are tackling one of the most critical, yet somehow surprisingly misunderstood parts of transitioning from Ethereum to Solana. We're diving deep into estimating and explaining costs, specifically looking at gas versus compute units. If you're building in Web3, writing great code is really only half the battle. The other half, making sure your protocol doesn't completely bankrupt its users or, your company. So grab a notebook, settle in, and let's unravel this whole thing together.
Ah, yes, the dreaded question. How much will this actually cost? You've spent weeks, maybe months, architecting this beautiful, elegant smart contract. You're totally ready to ship, and suddenly a stakeholder leans across the table and asks you for the bill. Cue the panic, right? Well, in our previous lesson, Mechanics of Gas and Compute Units, we basically built the engine. We figured out exactly how the EVM and SVM track resource consumption. But now we got to figure out the mileage. We have to translate those technical execution limits into hard, cold cash so your team can make actual, informed decisions.
Okay, here's our agenda for today. We're looking at a reproducible three-step workflow: measure accurately, convert to money, and communicate the cost. Then we'll wrap up with some mental models and a real-world example. Simple enough, right? Let's jump right in. Starting off with step 1, measure accurately. Now, look, you might be tempted to just run a quick local test, eyeball the numbers, and call it a day. But we need real rigor here. We've got to gather exact, unit-level metrics from a controlled staging environment that genuinely mirrors production. I mean, the exact same call data sizes, the same state, or at least a snapshot of it, and realistic input distributions. This is super important because what we extract from our execution traces is completely different depending on the network. For EVM-style chains, you're hunting down gasUsed, and ideally, you want those opcode-level breakdowns to see where the real heavy lifting is. But for SVM-style chains, you're looking for total compute units consumed and specific syscalls. Listen, an estimate with undocumented inputs is literally just a guess. You've got to document the exact trace you used. Moving right along to step 2, convert to money. This right here is the conversion phase. This is where your developer hat comes off and your accountant hat goes firmly on. We're taking those raw technical metrics we just grabbed and applying on-chain and off-chain pricing parameters. And you absolutely must follow a strict order of operations here. Number 1, calculate the native token cost. Number 2, add in your deterministic extras, those fixed fees like rent exemptions or account creation charges. Only then, at step 3, do you convert to fiat currency. Why? Because fiat exchange rates are wild. By isolating that native token cost first, you're building a stable mathematical foundation that doesn't just instantly vanish the second the crypto market blinks. So let's look at the baseline math. These are basically the fundamental gears of our cost estimation engine. On the EVM side, your nominal fee is just your gas used multiplied by the gas price, which obviously includes your base fee and priority fee. Over on the SVM side, it's your compute units multiplied by the price per compute unit set by the validator cluster. These formulas are your absolute ground truth for variable per unit charges. All right, step 3, communicate the cost. Honestly, this might be the trickiest part of the whole process. This is where you have to explain all that beautiful math to a product manager who fundamentally believes on-chain storage should be as cheap as like a Google Drive subscription. Spoiler alert, it's not. Your goal here isn't just to hand them a number, it's to give them an actionable narrative. Delivering a single point estimate, saying something like, oh, this transaction will cost exactly $13, is basically useless in a volatile environment. You have to do a sensitivity analysis. Present what-if scenarios. What if the network gets congested and priority fees spike? What if the user inputs massive cal data? Give them a conservative range. Document your assumptions for the upper and lower bounds, and show them the actual budget headroom. Let's shift gears a bit and look at mental models and margins. Throwing a bunch of raw data at stakeholders usually just makes their eyes glaze over. Instead, try using a layered mental model. We need to separate what we as developers can actually control from what the broader market dictates. I love comparing this to shipping a physical package. First up, you have intrinsic execution. That's your algorithmic complexity. Think of it as the unavoidable base weight of the cardboard box. Next is state change, things like storage reads and writes. This is your structural warehouse rent, basically the cost of keeping your data on the network. Finally, you have external constraints, your network fees. This is the totally volatile price of the fuel needed for the delivery truck. Breaking it down like this, it instantly clarifies exactly where your team can actually optimize. Now, what's really brilliant about this setup is how cleanly it separates our safety margins. Stakeholders need to understand exactly what kind of risk they are funding. If your algorithmic usage or input sizes bounce around a lot, you slap a 10 to 30% variability margin on it. Simple. But if you're dealing with a crazy fee market or native token price fluctuations, you need a price margin of 10 to 50%. Using a breakdown like this turns padding the estimate into a totally transparent, completely defensible risk management strategy. Okay, let's step out of theory for a second. Let's look at a real-world worked example. Imagine we're estimating a standard smart contract function. Let's say a simple token transfer that also writes a little bit of data to contract storage. How do we document this so it's actually useful? Well, here is our literal bill of materials. We've got our primary execution itemized right here, 120,000 gas multiplied by a 50 GUI unit price. We have our storage right isolated too. Notice how separating the deterministic fees from the variable ones just makes peer review an absolute breeze? If another dev wants to check your math, or if a PM demands to know why the fiat cost is $13, boom. Every single assumption is laid out transparently right in front of them. So to make sure your final written artifact is actually practical decision support and not just some glorified math problem, it needs a few core ingredients. 1. Document the exact trace used. 2. Show the step-by-step unit-to-native math. 3. And I cannot stress this enough, timestamp your fiat exchange rates. The price of ETH or SOL today is absolutely not going to be the price tomorrow. And finally, recommend some design mitigations. If you see that storage is just too expensive, suggest an off-chain index and show them exactly how much money that saves. Let's anchor on our core mantra one last time. Measure, convert, communicate. Run your traces in a staged environment, do the native token math first, and present your findings with transparent ranges and layered mental models. Mastering this workflow is going to perfectly tee up our next lesson, developer implications and next steps, where we'll actually use these estimates to drive real engineering trade-offs. So I'll leave you with this final, somewhat provocative thought. When you hand over a cost projection, are your estimates auditable blueprints that your team can confidently build on? Or are they really just undocumented guesses hoping for the best? Thank you so much for joining me in this Forge College Explainer. I really hope this framework brings clarity and confidence to your next big project. To learn more about this subject and to dive way deeper into Web3 development, make sure you visit us at forge.college. Keep building, keep measuring, and I'll see you in the next explainer.